All right, welcome to physics. Today we're going to be continuing on with our waves unit, and this activity will be more of a lab. So I have titled it as a lab, a wave combinator lab, and we're going to explore wave interference. And uh, theoretically, by the end of the next 2 days, we'll have a better understanding of how waves can be used to create noise cancellation headphones. So I think that's pretty cool. But day one here, we're looking at what this wave combinator lab, and so it is a game, and you have a couple different ways you can interact with it. I did my best to embed the game here. So if you click play game, um, it should just start working right here in the Go formative. If you prefer, though, you can click this. This is a link that'll take you to a new window and play. And I do encourage you to complete as many levels as you can. It's, if you've ever done Brain Pop before, uh, it's obviously educational, but it's pretty good stuff. And so this, by completing this lab, it'll help you get further and further, and hopefully uh, deepen your understanding is what I mean by that. You'll go further into your understanding of waves and how they're interacting. But what I want is, regardless of how interested you are, at least get to the second set of challenges. And so that'll be looking like this. Uh, but otherwise, just kind of showing you a little bit. And again, embedding it, getting the window size right, it was difficult and it didn't quite let me change it. Um, but you can hopefully still be able to interact with it, use these arrows. And again, the second set of challenges is where I want you to go. So you have to do this wave playground, and then it goes to wave or challenges one, and there's a few, and then it goes to random, I believe, and then it brings you up to challenges two or possibly pulse. Can't quite remember, but I want you to try and get to here. So you start by clicking that, and it's going to walk you through it. Look at all these cool buttons. Wonder what they all do, right? You click next. So it's quite literally like a computer game. Try dragging the sliders, see what they do. Okay, so as you do this, you can see that I'm moving the wave to the right or the left. I can change the wavelength by stretching out the wavelength or shortening the wavelength, which, based on our last activity, we can see that that increases the frequency. And we can increase the height or the amplitude, right? So we get to play around with some of the characteristics that we did last time. Ooh, there you go. There's my little playground. So now I'm here for challenges one, right? So uh, a lot of these challenges are going to be getting them to match each other. And so by simply moving this, I got my line to match inside there, and then I can click next. And so now I got to change a couple things to match these frequencies. And uh, we're going to learn more about what that is actually doing. But this is something that is happening all the time when we talk about like radio waves and radio signals. Um, this is what those signals are. That they're multiple layers of waves that are combined in order to hold information within them, and then a receiver, like what we would call a radio receiver, can interpret those signals and then play music or whatever's being broadcast, right? So uh, this is a very brief introduction, but again, I would encourage you to go as far into, I think, the menu. Yeah, as far into this as possible. I mean, there's 5 challenges. In the least, I'm hoping you get here. And based on what I've done, I believe it takes 10 to 15 minutes to get here. So I would encourage you to go further, though. Okay. Then Uh-oh, something's not loading. Oh, that's like it's not loading. Then I have a couple questions. Okay, what is the difference between constructive and destructive wave interference? And then before we continue on with the part two, I want you to make a prediction. How do you think noise canceling headphones work? And please don't look this up. I'm not asking you to research anything, but go ahead and make a hypothesis, make a prediction, and then you're ready to continue with part two. Again, though, for CDL students, you're welcome to do the whole activity all in one go, however you like, or you can split it into two parts. But if you are an in person hybrid student, please pace yourself, complete day one today, and then complete day one or day two, I mean, the next day, right? That way, when you come into class, it kind of guarantees that we have something to do and work on together as well. So, with that being said, this next part is a little PDF, and it has some reading to help us understand what we just did with constructive and destructive interference. It's got these models. Okay, so I do want you to read this. In here, it does talk about um, noise cancellation and how that works. And then we also have a demonstration here where you can hear the constructive and destructive interference based on where you're standing. So I want you to watch this demonstration and then think of an experience in your life where sound interference occurred. Um, oh, and I had this from the previous. This one didn't work out too well. Not too many students wanted to share in class what kind of experiences they had, but go ahead and type it in here. Okay. I meant to erase that because it didn't go as planned. So I won't worry about that. But just think of an experience where sound interference has occurred in your life, or you might have experienced this, and then uh, go ahead and type that experience in there for me. Okay. So hopefully this is fun, and hopefully we'll have a better understanding of how interference can be constructive or destructive, and what that means. Like, what do we experience when that happens? As always, please let me know if you have any questions.